everyone, Assalamualaikum and welcome back to this presentation video. My name is Ikra and today I will be presenting on behalf of my group. Our topic is something super important in calculus, differentiate. If you are currently learning calculus, preparing for exams or just trying to understand derivative once and for all, this video is definitely for you. Alright, let's get started. Before we jump into the content, let me introduce my group members. Even though I'm the only one speaking right now, this project was created by all four of us, Ipan, Daniel and myself, Ikra. Huge shout out to my team for the effort and teamwork. Now, let's move on. The first question for our group was assigned is, explain the meaning of differentiate and what are the techniques of differentiate. It sounds simple, but differentiate is actually a core concept that appears in engineering, physics, economy, and many real-world problems. So, understanding it properly is really important. Let's start with the meaning. Differentiate is basically a mathematical process that tells us how fast something changes as something else changes. For example, if you have a graph of distance against time, differentiate can tell you the instantaneous speed at any moment. So if we have a function y equal fx, its derivative, which we write as f prime x, show how y react when x change. Another way to think about it, differentiate tells us the slope of a curve at a specific point. If the slope is positive, the graph is increasing. If it's negative, the graph is decreasing. So it's not just number. Differentiate is actually describe behavior, movement and change. Now, let's look at the technique of differentiate. That's the main rule that makes solving derivative much easier. First, the power rule. If you have x raised to a power like xn, then the derivative is nxn minus 1. This is the one of the most commonly used rule. Next is the product rule. This rule is for when two functions are multiplied together. We call them u and v. The derivative is u prime v plus u v prime. It's basically differentiate one multiply the other then switch. And the third one is the quotient rule. It is for function in fraction form u over v. The formula is u prime v minus u v prime over v square. It's a rule that students often miss out, especially the minus sign. So memorizing it properly is important. Alright, now let's go through 3 more essential techniques. The fourth one is the chain rule. This is used when you have a function inside another function, a composition. The idea is derivative of the outside multiplied by derivative of the inside. Then we have implicit differentiate. This happens when y cannot be separated from x, like in the equation of circle or more complex curve. We differentiate both sides normally, but every time we differentiate y, we multiply by dy over dx. And lastly, we have differentiation for trigonometric, exponential and logarithmic function. For example, the derivative of sin x is cos x and the derivative of cos x is minus sin x. These formulas are fundamental because many exam questions combine them with the other rules. And that's all from me. Bye.
Hi everyone, today we're going to find the derivative of the function y equal to 3x squared sin 2x and differentiate y equal to sin x cubed minus 2x squared plus 1. Since this function is a product of two expressions, 3x squared and sin 2x, we'll use the product rule. So first we identify u prime, v and v prime. Let's set the u equal to 3x squared. When we differentiate that, we can get u prime that equal to 6x. Next, let v equal to sin 2x. To differentiate v, we use the chain rule. So we get the v prime equal to 2 cos 2x. Now we substitute everything into the product rule. That becomes dy over dx equal to 6x multiple sin 2x plus 3x squared multiply 2 cos 2x. And we simplify it, so we get the final answer is dy over dx equal to 6x sin 2x plus 6x squared cos 2x. Next, let's solve question B. Since this is a composite function, we must use the chain rule. First step, we identify the inner and outer function. So let's set the inside function as u equal to x cubed minus 2x squared plus 1. And the whole function becomes y equal to sin u. Second step, we differentiate each part. Now we differentiate the outer function with respect to u. So we get the dy over du equal to cos u. Next, we differentiate the inner function. So we get du over dx equal to 3x squared minus 4x. After that, substituting everything in, we get dy over dx equal to cos u multiply 3x squared minus 4x. And finally, we replace u back with the original expression. So our final answer is dy over dx equal to 3x squared minus 4x cos x cubed minus 2x squared plus 1. That's all from me. Bye-bye.
Question 3. We will be using implicit differentiation to find dy over dx for a complex equation. Our equation is e raised to the power of 2x plus 1 minus x squared times the tangent of 2y plus the natural logarithm of x times y equals 0. Step 1 is to differentiate both sides of the equation with respect to x. Remember, whenever we differentiate a term containing y, we must multiply by dy over dx using the chain rule. Let's differentiate term by term. The first term e 2x plus 1 differentiates 2 times e to x plus 1. The second term, x2 tan 2y, require the product rule and chain rule, resulting in the expression minus the quantity of 2x times the tangent of 2y plus 2x 2 times secant square of 2y times dy over dx. The third term, ln xy differentiates to 1 over x plus 1 over y times dy over dx. After that, rearrange the equation. We group all terms containing dy over dx on the left side and move all other terms to the right side. Then factor out dy over dx. The final answer is dy over dx equal to the numerator, which is 2x times the tangent of 2y minus 2 e to x plus 1 minus 1 over x divided by the denominator, which is 1 over y minus 2x 2 times secant square of 2y. In short conclusion, implicit differentiation requires consistent use of the chain rule, algebra manipulation to isolate dy over dx, and final solution. Thank you.
Question 4. Before we start, the question is use linear approximation to estimate the value of the square root of 15.98 divided by 3 minus the fourth root of 15.98. Step 1. We rewrite the expression as a function, the square root of x divided by 3 minus the fourth root of x. Since 15.98 is close to 16, we will approximate around x equal to 16. Step 2. At x equals 16, the square root of 16 is 4, so we get 4 divided by 3. The fourth root of 16 is 2, so the function value becomes 4 divided by 3 minus 2, which simplify to negative 2 divided by 3. Step 3. First, rewrite the function in exponent form so that it is easier to use the differentiate rule. Second, apply the power rule, which states that if we have x raised to the power of n, its derivative is n times x raised to the power of n minus 1. Third, simplify the exponent. The result becomes 1 over 6 times x raised to the power of negative 1 half minus 1 over 4 times x raised to the power of negative 3 quarters. Next, I rewrite with radical and positive exponent. So the final derivative is 1 over 6 square root of x minus 1 over 4 fourth root of x cubed. Step 4. Compute f prime 16. When we substitute x equal 16, the square root of 16 is 4 and 16 raised to the power of 3 over 4 is 8. So the derivative becomes 1 divided by 24 minus 1 divided by 32. When simplify, this gives 1 divided by 96. Step 5. I use the linear approximation formula. We take the function value at 16, which is negative 2 divided by 3, and we add the derivative at 16 multiplied by the difference between 15.98 and 16. The difference is negative 0.02. When multiplied by the derivative, we get a very small negative value, 1 divided by 4,800. So the approximation becomes negative 2 divided by 3 minus 1 divided by 4,800. Step 6. In decimal form, this is approximately negative 0.666875. When rounded to 3 decimal place, the final answer is negative 0.667. That's all from me. Thank you.